Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900. Tonight, Friday, we're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So right now I'm in the cockpit of the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments and displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The display is the airspeed indicated. The airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude of the outside atmosphere, and also the barometric altitude above the sea level. The target altitude selected from the autopilot, flight director system panel. The vertical rate of climb of the aircraft in 10,000 feet per minute. All the signals of the trigonometric angles and degrees can climb and descend. We have also the altitude indicator with the artificial horizon, the bank angle in degrees, and the pitch ladder in degrees. We have also the ILS localizer, the instrument landing system of the airport runways we use for takeoff and for landing. So we have the threshold antennas that transmit the radio frequency. And also are received from the onboard antennas of the aircraft, so we can align the aircraft with the runway heading when we take off and when we land, and also use the angle of approach, the glide slope. So we have the display of this information of this data in the primary flight display. We have also the ILS localizer cross bus. We have the flight director cross bus for manual guidance of the aircraft, and the autopilot cross bus for automatic guidance of the aircraft. The angle of attack of the aircraft as it flies in the flight mode and zero with the autopilot and the auto throttle. Later in vertical navigation modes, we have also the edge side that displays the horizontal situation indicator. With the terrain, with the magnetic heading and track, and also the integrated display of the flight plan. So we're gonna create a flight plan using the flight management computer. Later I will input all the data of the aircraft for this flight. So we will create, it will show us a purple onward data line. We need to follow in flight either manually or automatically using the autopilot flight director system panel. So you can see here the flight management computer, the autopilot flight director system panel, the primary flight display, the navigation display, the ACAS, the engine indication controller system display that displays the FAREX, the full authority digital engine control computers that control the engine's functions. We have the flight control computers, the air data computers, and the flight control surfaces, other computers. Also in the aircraft, I will show you their function. So we have this. We have also the navigation display. The navigation display that displays the GPS position, the magnetic North Pole and the geographic North Pole, and magnetic variation depending on where we are in the world. We have the terrain and weather reflections from the weather radar. You can see the red, green, and yellow indication of the terrain around you, in front of you, or below you. And also depending on the distance of the terrain, and also the altitude difference with the aircraft as we fly. Also we have red, green, yellow, amber, and blue for the sea, the lakes, and the rivers. So we can see also the aircraft when it's flying above the ground in the vertical display. We have also the terrain map with the airports. You can see the airports, the airport we are located, the runways and the taxiways we're gonna use for takeoff and for landing are displayed. Also from the GPS receiver, you can see the runway length and its heading. We can see the board stations, ADFs and DPs, the navigation aids, the nav aids of the aircraft. We can use also the waypoints which are horizontal and vertical navigation fixes and altitude and airspeed constraints. We're gonna use some waypoints using the flight management computer over here when we fly. Before flight, actually, we're gonna input all the data of the aircraft for this flight. So we're gonna create a flight plan or a flight path or a route. It's gonna be displayed as I told you with a purple color. Also, it's gonna be followed from the autopilot flight director system panel. We connect the autopilot. So also in the navigation display, you can see the magnetic North Pole, geographic North Pole, magnetic variation depending on where we are in the world. We have also other aircraft that fly around our own aircraft are displayed using the transporter. There is the ADC transmitter receiver, transmits our frequency to other aircraft, and the air traffic control and receives from other aircraft. You can display, you can calculate from its computer using the radio frequency difference, where the other aircraft are located, the distance from our aircraft, the altitude difference, how many hundreds and thousands feet are above or below our aircraft. You can calculate the distance, the bearing, and the position also. It can calculate whether they climb or descend with respect to our aircraft. It can also calculate the velocity closing in between our aircraft and the other aircraft. It gives us a warning from the TCAS system, the Traffic Collision Advisory System. We can see the diamond shape of the other aircraft displayed in the navigation display up to 40 nautical miles or 72 kilometers away from our aircraft in a 360 radial degree. So we can see also from the TCAS system we have a warning in the air. We'll make an avoidance maneuver. Also we can see in the ground, in the runways and the taxiways where the other aircraft are positioned from the transmitter receiver. So we have also this is for the navigation display. We have also other displays. We have the flight controls here. I will show you my computer, my mouse pad here. What I use is also the keyboard to input the data I need in the flight management computer in the autopilot flight director system panel. Also the flight controls here. I have a side stick, Logitech Extreme 3D identical to the Airbus side stick, so we can climb it with descent. We move the side stick back and forth, so the yoke of the Boeing aircraft is moving back and forth instead. And also we use the side stick left and right. You can see the control wheel, so we can make left and right turns using the ailerons and the spoilers. Also we can use you can see the deflection of the side stick is the same like the yoke, like the control wheel or control column. So there is no difference in the flight controls of the Boeing or the Airbus. We have also the rudder pedals. So over here we can control the vertical tail rudder, moving left and right the rudder pedals. So we can use the nose wheel steering together with the rudder. Also you can see some flight controls are interconnected in the Boeing. They move together, both the captain and the first officer, unless we apply some force in either side to override the other flight control. So we have also this for the nose wheel steering, the tiller over here. So we have also the thrust levers here. You can see I can use this for the thrust levers over here, this slider, so we can move forward or aft. It will display us in the FAREX. From the FAREX, the Flught or digital electronic engine control computers, you can see the position the engines are right now, the thrust commanded. So we move full takeoff thrust like this. As you can see, it will give us some warnings. We're not configured for takeoff right now. So we'll see all the flight controls before we go into flight very quickly. Also the primary flight display, we're gonna see over here the autopilot flight director system panel, the flight management computer over here. We're gonna create the flight plan. You can see also the landing gear, extend and retract, the alternate gear over here, the lock override, the auto brakes system. I will show you later. So we have here the primary flight display. You can see the airspeed indicated, the airspeed tape, the airspeed selected from the autopilot flight director system panel. We have the barometric altitude above the sea level. With this barometric pressure, this is the altitude tape, and the target altitude selected from the autopilot flight director system panel. The vertical rate of climb descent over the aircraft in tens, hundreds, and thousands of feet per minute, like 500, 1000, 1000, 500, 2000, 3000, 6000. So you see this needle moving up when we climb, moving down when we descend. We have also the artificial horizon with the altitude indicator, the flight director crossbars, this purple. So we have the pitch ladder in degrees, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down. Also the bank roll of the aircraft, you can monitor like 5, 10, 20, 30, 40, 5 degrees. Make right and left turns, and also the side slip indicator. Also you can see the wings of the aircraft. This L black symbol is the wings level. When we fly, you're gonna see them moving around. The radio altitude above the ground, the HSI, the VOR ADS connected. Also the terrain in the navigation display, the magnetic North Pole, geographic North Pole. Over here you can see the distance is 80 nautical miles away from us, range, track magnetic. So we have this is the EDTL, is the Düsseldorf airport in Germany. You can see it says EDTL, so we're gonna be flying close to that later. This is the Zurich where we are located right now, Zurich airport. So here's the Switzerland, here's the Germany. If we look closer away, you can use the switch over here to change the range, also the plan, the display, see other things. So we have the plan now. You can see over here is Germany, France, and the Switzerland down here, these airports. We can see also, if we look closer, we use the range closer over here, change the view of the maps. So you can see like 20 nautical miles away, you can see the terrain we're gonna be flying in front of us in the vertical display over here. You can see 0, 10, 20, 5 and 15 nautical miles away. You can see the green and yellow indication. Later you're gonna see also red displayed somewhere. Also the altitude we have selected from the autopilot to fly. So this is some of the information we need to know for the aircraft. Also we look even closer, you're gonna see more mountains when we fly. If we fly at low level, you can see the aircraft, this triangle, and the altitude we're gonna be flying above, so you can see the mountains, like 10 nautical miles, 18 kilometers is all this terrain around us over here. So it's in front like this. We'll see later also the taxiways and the runways. So we have here the barometric pressure, the barometric altitude here set 29.92 inches of mercury. It's set from here from the FIS panel, electronic flight instrument panel. You can set bar set inches of mercury, so we have 29.92 inches of mercury, 1013 hectopascals right now. We can change that later. We have radio, battle, weather radar, traffic, terrain, also systems, CDU, info, checklist, communication. Over here you can see navigation display, checklist, engine, SafeCast, left and right, accept, cancel, reject, some warnings over here. The autopilot and flight director later. You're gonna see also. So I'm gonna show you all the flight controls and systems of the aircraft before we go into flight very quickly. For this flight we have not much time. So we're gonna see also over here a few more things to see. So we're gonna make an engine start demonstration going to complete flight. You can see the fuel flow for the left and the right engine, the left and right engine thrust control over here. Also the speed brakes and the flaps position. We have everything we need for this flying over here. So we can retract the flaps, extend them again. Fuel control and also the stabilizer trim cutoff switch. The alternate trim over here. So this way you trim the elevator up, this way you trim the elevator down. Pitch the nose of the aircraft up and pitch the nose of the aircraft down. Also the parking brakes on and off like this. Stabilizer trim cutoff. So this is the trim cutoff switch for all Boeing aircraft. Also we have the normal over here stabilizer trim. As you can see, we can trim the elevator up, trim the elevator down using this switch. So this elevator left click down, right click up, the flap speeds over here. So this way you pitch the elevator up, this way you pitch, you trim the elevator down, you trim the elevator up, you pitch the nose of the aircraft as you fly up, and you pitch the nose of the aircraft down as you fly. Elevator trim, left click down, right click up. So we're gonna see also the rest of the systems very quickly. So you can see here we have the elevator For climb and descent, we use the side stick or the yoke to climb and descend the aircraft like this when flying. So this is for Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, Boeing 787. You can see this stabilizer cutoff switch from normal to cutoff, and also the alternate trim. This is a fly-by-wire aircraft. It has its flight control computers. So a fly-by-wire aircraft, it has its flight control computers. Like in the Airbus aircraft, we can make we have the flight control computers, the normal, the alternate, and the direct mode, and also the backup mechanical modes. So we have failures of some systems that affect the flight controls or the engine function. We may have the grade of the flight control modes. In normal mode, the Airbus, we can make left and right turns, 67 degrees, full stick deflection, or 33 degrees if we leave the stick off. And also this accounts for 2.8 g, where 1 g is the acceleration of gravity in left and right turns, limited from the flight control computers. Also we can climb 30 degrees and like 1.5 g, or we can descend 15 degrees or minus half g in the Airbus aircraft. Also we have the alpha protection and the angle of 1g stall and other protections, speed protections. So we have also similar things in the Boeing aircraft. It's fly-by-wire now. So when we move the yoke of the Boeing aircraft, we command the flight control computers to make changes in the flight control surfaces instead of having the hydraulics of the older aircraft. So this is the function of the fly-by-wire aircraft. So this is for all. If we have failure over here of the hydraulics, you can see left and right engine driven and electric C1 and C2. That will affect the primary flight control computers function from normal to alternate or direct mode. We cannot lose the auto trim function from the autopilot flight director system panel, because both the Boeing and the Airbus aircraft now have the auto trim. They can trim automatically the horizontal tail instead of trimming manually like in the fighters, like in the F-16. So you can use if you have this failure, you need to come down here. This is for Boeing 737, 747, Boeing 757, 767, and Boeing 777 and 787. So you move this red guarded switch open, and from normal either left and right horizontal tail stabilizer to cut off. Then you lose the automatic trimming, also the autopilot. This makes the auto trim cut off the auto trim, so you use only the alternate or direct manual trim switches over here, as you can see. So we have the alternate over here, horizontal trim stabilizer, trim up and trim down like this, elevator trim, left trim, pitch down, pitch up. Also we have the parking brakes over here, and we use also the manual trim switch over here in the control wheel to trim the elevator up and down. So we'll see now. I will talk to you now about Newton's physics, aeronautical and aerospace engineering. We need to know some principles of the flight dynamics of the flight. For the air transport pilot license, the ATPA license, or the commercial pilot license, the CPL license, we need to know the flight dynamics. So we're talking about Newton's physics and the new theory of fluids, and show you the outside view very quickly, explain you some facts we need to know about the aircraft, and also show you the flight controls very quickly. So you can see the outside view of the aircraft. The aircraft wings hold the weight of the aircraft when the aircraft is flying. The weight is divided over the surface area of the wings that produce the aerodynamic lift force that lifts the aircraft weight up into the air and overcomes the weight down, overcomes the weight. So we have also the thrust that overcomes the drag that moves the aircraft forward from the jet engines over here. So we have turbofan turbojet engines. We have the vectors from the turbofan turbojet engines. You can see we have the low and the high pressure. We have the low, we have the high pressure compressor and turbine, the high speed starter shaft in the back section. Also the high speed starter and spool and shaft, and also the front fan and the low pressure compressor in turbine, the low speed starter and shaft in the front stage, the combustion chamber. We have the fuel lines coming down here from the left and the right wing, fuel tanks over here where they allocated from the fuel booster pumps that boost the fuel into the engines. We have the wing and engine RDIs. We have the front fans from the engines, turbojet engines, the exhaust gas over here, and the bypass air from the front fan. So we have bypass air for turbofan turbojet engines. So we have the wing and engine RDIs over here. We have the main aerodynamic core, which is 23% of the main aerodynamic core, where the maximum aerodynamic lift occurs. Also the center of pressure is moving back and forth in the wings. Also the stall, the airflow becomes detached from the top surface of the wings and the wings are stalled in flight. So we need to monitor all the time when flying. We see the airspeed here indicated. We have the stall speed with red and yellow just below the airspeed. Also the thrust here. We apply a nose down yoke or side stick if we have the Airbus, yoke if we have the Boeing, and the thrust levers forward to increase the thrust to make a stall avoidance. So we'll see mean aerodynamic chord position where the maximum aerodynamic lift occurs. Also is the center of gravity over here. What is the yawing axis? We can yaw the aircraft like this, left and right using the rudder. So the rudder yaws the aircraft left and right, as you can see. So we have this axis of control. We have also the nose wheel steering over here to yaw. So in order to yaw, you use the rudder pedals, as you can see in every airliner aircraft like the Boeing or the Airbus. So we can make left and right turns using the rudder pedals. Also using the nose wheel steering from 0 knots from the computers. It is interconnected, we don't need to do nothing. Up to 45 knots, like 72 kilometers an hour, the nose wheel is moving left and right 76 degrees. Then at 45 knots, like 72 kilometers an hour, the nose wheel is decreased to 7.6 degrees. Deflection from 76 automatically from the computer, because we have the rudder aerodynamically effective at 45 knots or 45 knots or 72 kilometers an hour. So we use mostly the rudder after above 45 knots. So at 80 knots airspeed or 144 kilometers an hour, for the forward nose wheel is locked to 0 deflection from the computer, or like half or 1 degree, very small deflection. Above 144 kilometers an hour or 80 knots, we have only the rudder to control the aircraft, both in takeoff and in landing. In landing we have the inverts. First we have the rudder, then the nose wheel coming in as we slow down the aircraft. So this is a very simple explanation. You see the rudder pedals and act both in the rudder and the forward nose wheel instead of using the tiller. Also we have the toe brakes. We can press the brakes and stop the aircraft. We have one more axis here, is the pitch axis. From wingtip to tip we can use the elevator for climb descent over here, like this, elevator up and elevator down, climb descent. In the Airbus side stick back and forth. In the Boeing we have the yoke for climb descent, like this, climb descent, the yoke. Also in the Airbus and the Boeing aircraft we have, all aircraft actually, one more axis is from nose to tail, is the longitudinal axis. We can make left and right turns using the side stick in the Airbus, left and right, or the Boeing we use the control wheel. We use the ailerons and the spoilers to produce aerodynamic lift difference between the left and the right wing. In the Boeing also we have the aileron spoilers and the flaperon. So we have aileron spoilers and one flaperon here and in the other side. So side stick left and right turns, both Airbus and Boeing. Same flight controls, no difference. Also we have in the Airbus the side stick priority button, the push to talk, and the autopilot disengage switch over here. So I will show you one more view now of the flight controls of the aircraft. Then we're gonna make the flight management computer and make a full flight demonstration. So now you're gonna see one more view here of the flight controls of the Boeing 787. So we can see here, so we can climb, we can descend, we can make turns to the right, turns to the left like this. So very easy to remember. You see the side stick deflection is proportional to the yoke deflection of flight controls. Also use horizontal trim stabilizer. Over here the thrust control thruster levers. Over here you can move the thrust commanded by the engines. So very easy climb and descent. Make turns to the right, make turns to the left, like in the Airbus and the Boeing. You see no difference in the flight control system. Also we can use the outside view. Over here make left and right turns very quickly. So left and right turns, also climb and descent, rudder pedals. Left and right turns, aileron spoilers, flaperons, rudder pedals, rudder control, and also the elevator. So the elevator takes the weight up and takes the weight down. When we move it, when we fly, so this is most of the flight controls we need to know right now. Hope you like it. Now I will show you the flight management computer. I will explain you the rest of the systems before going into flight. So very quickly we're gonna make the engine start demonstration over here. So you're gonna see now the engine start demonstration of the Boeing 787. Very quickly I'm gonna set up the flight management computer, then we're gonna make an engine start demonstration. So you can see I have the mousepad here, and here the keyboard to input all the data we need for the aircraft, also the side stick. So we input the data through here from the flight management computer. I will use the index, you see the position, performance, takeoff, flight plans over here. So we use also the mousepad, this screen over here. So we'll show you maybe this view. Control quadrant over here. So the inside view one more time. So we have identity, position, performance, approach, and unseat status over here. So we have the identities: Boeing 787-900, GNX engines, Iraq cycle. Position, we can use Lszh airport, Zurich International Airport, Lszh in Switzerland. The coordinates, we can align the IRS like this with the GPS position in the magnetic North Pole. The fuel on board the aircraft, and the gross zero fuel weight, fuel on board, and gross weight for takeoff. Reserve fuel, cruising altitude, cost index, fuel freezing temperature, and the center of gravity. So we use the route very quickly. Lszh airport over here, departure and destination, back and forth, same things. Copy paste. Then we use runway 14 over here, departure and arrival. So we have the departures, use runway 10, 14, 16, 2832. So we can use runway 14 and the Zui 2 alpha. The seats are the instrument departure waypoints and fixes. Also arrival, departures, arrivals. Oh, we have destination, and let's see it. We didn't paste it. Copy paste over here. So we have arrival here. We can use the stars. Approaches VOM 162834 ILS 14 ILS 16. Instrument landing system, runway ILS 28 ILS 34 runway 34, GLS 14, localizer 28, localizer 34. So we use ILS 14, stars trans Amiki, transition waypoint. In the air and the stars are the southern terminal arrival waypoints and fixes. We use Negria 1 Alpha. We have the legs here. The route is displayed with blue. We need to activate. So we need to come here. Route 1 legs. In the route, clear the discontinuity. Initialize 0 fuel weight. Fuel on board, the reserve fuel. Cruising altitude 25,300 feet. We're gonna fly over there. Also the coast index 100%. Fuel freezing temperature. Cruising center of gravity. Execute. We activate the route like this very quickly. So the route is activated. First waypoint after takeoff was over here. Route Lszh departures over here. Zui 12 execute. So we have the intercept. Negria Mativ. So this is the complete flight plan. The autopilot we follow. This route, one waypoint by another from takeoff, climb over here, cruise, descent, approach 0701 and runway 14, initialize, flaps 15 degrees over here, center of gravity trim 23%, 4.25, and the takeoff speed V1, we rotate, and V2. So we need to come here in the virtual cockpit again. We have set the flight management computer. We're gonna show you now in the overhead panel the engines indications. You're gonna see here from the FAREX very quickly. The N1, which is low speed starters, have low pressure compression tube and the engine exhaust gas temperature, and 2 fuel flow principle are 1000 kilograms, 1000 pounds, oil pressure, oil temperature, quantity, vibration of the N2 stage of the engine, gross weight, and also we have the bleeder pressurizer over here. We can use so you can see the bleeder, the pressurization of the aircraft when we climb and we descend, the forward and the aft, outflow valves, cabin rate, differential pressure, stabilizer trim position, rudder trim, flaps position, landing gear, external retract, gross weight for takeoff, fuel on board, and the temperature. So you can see the pressurization of the aircraft. You can control pressurize and depressurize the cabin. Also, I will show you the data now before we go into flight. So we need to start the engines over here. I'm gonna use the APU one like this. Start the APU. So we have the left and the right IDG, the great drive generator, 100 200 volts, 400 Hz regular to the battery, APU generator, primary flight control, computers in the auto position, flight data computer, flight control, surfaces over here, the battery, towing power FD door over here, passenger oxygen, window heat, rammer turbine over here, left and right, wing energy. So we will turn off the hydraulics, primary demand. You will see what they display over here. Also the electric C1 and C2. So we turn back to the auto position after the start. So we have also the recorders, the cargo and APU fire over here. The electronic engine control for the engines, also controlled by the FAREX. We can use the auto start to start the engines like this. Fuel jettison, we can dump some fuel, select the nozzles and how much fuel to remain. We make an emergency landing. So important to remember the engines controlled here, the auto start. We have the fuel also, fuel booster pumps, left and the right wing, center tank, and the cross-free valve. We would turn it on if feed either engine with either pump or balance the fuel between left and right wing, and also either pump or either tank. So this is the fuel valves, fuel booster pumps. We have the pressurization here. So we climb, we use the outflow valve open to the pressurizer. When we descend, pressurize, close. Also the wing energy radii on auto. We have pressurizer from the wings, from the engines and the APU for cabin pressurization, wing energy radii, cabin pressurization, hydraulic fluid pressurization, oxygen inside. we have an aircraft coming for landing. So now we go for doing the engine start demonstration. Last thing to see before flight. So you can see now we have the runways here, the taxiway. We can see the taxi with the runway. We're gonna use for takeoff and for landing the taxiway, the GPS in front of us. Also the other runway, also the center view. Like this, you see the whole airport. So this is the taxiway in front of us and the runway in the side, just like the outside view. Also the mountains. When we fly, also we can see the flight one waypoint by another. What we need to follow here in flight. If we increase the range, you will see more flight plan. Also the vertical display and the horizontal. So you see the waypoints, the stars here for approach and landing, the runway, the terrain elevation, the other side flight plan, the edge side display. We have also this view over here. So you can see the runway, the aircraft where it is located, the distance from the runway. You can use that for takeoff, for landing, the map setting. Also we increase the distance. You see more waypoints, the purple line, that is the flight plan we have created. More airports also when we fly, the blue symbol, the blue name for letter name. So we go now for takeoff. We need last thing before do couple last things, the systems of the aircraft. So we have the system. You can see the hydraulics over here, the APU, the oxygen liquid cooling over here, oxygen liquid cooling, the electric. You can see left and right engine driving IDZ, the great drive generator, 100 to 200 volts for 100 Hz frequency. The APU is running, the main battery, and the APU battery, charge and discharge, the load set over here, drive, connect, disconnect. Also we can see the hydraulics, where the hydraulic fluid goes, which system use hydraulic fluid over here, like the flaps, primary demand, left and right engine driving, shuttle valves and isolation. Also we can see the pressure of the hydraulics, 5100 psi, and the quantity of hydraulic fluid, the fuel on board the aircraft, left and right wing and center tank, left and right engine. Also the minimum fuel temperature, minus 37 degrees, below which the fuel will freeze in flight, and minus 6 degrees the fuel temperature right now. So the FAREX recirculate automatically in flight the fuel from the wing tank and the center tank to the engine components to heat up the fuel, also the lubricant and the oil. We have also the low and high pressure. The FAREX do that automatically, we don't do anything. We have the low and high pressure fuel valves, open and feed both engines from the center or the wings. We have the fuel forward and aft fuel booster pumps. The crossfeed valve with the tonic feed either engine without power right the tank. The APU is fed from the left wing using this motor. We have 11,000, 11,000 and 12,000, total 34,000 pounds of fuel. The air pressurizer, cabin pressurization, oxygen, the packs. Also the doors are closed, the cabin can be pressurized. The gear, you can see the pressure of the tires and the temperature of the brakes. Also the nozzle, flight controls, left and right wing, flight controls, movement, the tail, horizontal and vertical tail, also the rudder pedals, and the horizontal trim stabilizer. So this is one of the last things we need to know before going to flight. I'm gonna show you the engine start demonstration. So we have the FS display over here, maintenance over here, systems, circuit breakers, systems, back, checklist, the normal menu, what we need to do before start, after start, descent, approach and landing. Also communication. So we go back to the navigation display. We'll see now, we turn off the engines, both of them. Fuel control in the off, fuel valve in the off position. So you'll see the message, we have the fuel booster pumps off, and the engines are decreased. So we need to start also the lights over here, a little bit more lights, and start the auto start system over here. So we start the auto start position over here, the engine. So we see the configuration, the yellow switches, our switches. So now we have pressurizer into the N2 stage. You can see only pressurizer from the APU is coming into the engine. We have no fuel yet, so we increase the pressure inside the engine. So we admit now above 30% N2, the fuel control in the on position like this. So you see the auto start is coming in very quickly. N2 and 1, all pressures are stabilized. N1 which is low speed south and south, N2 which is high speed south and south, high press compressor and turbine, low press compressor and turbine, fuel flow, exhaust gun, temperature, oil pressure, oil quantity. So we have above 62%. I'm gonna be having the running engines with green methods. So now we use the flaps in the up position like this. Speed brakes are retracted over here. So we need only to set the autopilot here, auto throttle left and right. As you can see, the airspeed will decrease. You can set the airspeed what we need for this flight. You can set the LNAV and the VNAV like this. We can turn off the flight director. The modes will turn on and off again. Autopilot engages. So bank angle auto. The heading, we're gonna set the heading of the runway. We have here for flight 136 degrees over here. Vertical speed, so we can descend like this. Leveling off, you see 0. Descend, you see minus sign, like a minus 2,500 feet. Or climb, you see the plus sign, so we climb like 3,500 feet per minute. Also we can use the altitude, we can use thousands over here for climb. Thousands and then hundreds. So we can taxi into the runway for takeoff. We're ready, parking brakes off, advance the thrust levers, take the clearance from the air traffic control over here. We use a bit more flaps. So we have the runways open for us for takeoff. Advance the thrust levers again. Runways open. Use also the tiller here for alignment of the runway. So we are aligned with the runway center line for takeoff and for landing all the time. Use the tiller for this case. So we advance the thrust levers, as you can see, forward to takeoff position, full takeoff thrust. So we push the yoke down of the side stick and also use some rudder pedal until 80 knots. We have the yoke or side stick down. We have 100 knots. V1, we rotate. Over here we pitch up 9 degrees for rotation, as you can see. So we have positive rate of climb, landing gear up. So this is the positive rate of climb. Over here we take off, and we have a few more minutes to go for flying, as you can see. So we keep climbing, as you can see. So you can see we are 2,200, 2,300, 400 feet above the ground, but 4,000 feet above the sea. The airspeed is 190 knots. We have the bank and also the pitch altitude right now, like 17 degrees. The stall speed, yellow and red. The wind direction, speed, the terrain, red, green, yellow. So you can see how fast we climb. The altitude is increasing. Also you can see the flight plan we have to follow, and the crossbars of the flight director. So we need also, if we look closer a little bit, you will see the terrain just below us as we're climbing through the departure. Here you can see we are like 4,000 feet above the ground over here, so we have the terrain. If we pitch, if we're leveling off. So this is the vertical display of the aircraft, and this is the horizontal flight path as we fly. So we need to start the turn now, as you can see, and we have like a few more minutes for this flight, like 18 more. So we start the turn like this. $18 more minutes, perhaps, maybe less, for coming back to the airport. So we align over here. You see the air dot icon are correct, as you can see. We need to follow this flight path, the airspeed over here as we fly, the stall speed red and green and yellow, the altitude, the vertical rate of climb, the pitch ladder, also the flight plan, the wind direction, speed over here, barometric pressure, the engines indication and the flight plan. Again, also the other waypoints, the engines over here set, the flight management computer. We can use the legs here. So if we climb, we can use also the other side over here. It's a bit less view. So we look outside, we see the view, the Switzerland, the lakes over here. Very beautiful view as we keep climbing. The Germany, my homeland over here. We're gonna be overflying the Germany in a few minutes. So we have the view inside after takeoff over here. So we keep climbing. The airspeed heading altitude and vertical speed. We need to connect the autopilot. Couple of minutes, maybe, if we have some time. We need to align also with the flight plan as we're flying. So this is the most beautiful view you can have right now with the aircraft as we overflying the Zurich and the Switzerland over here. So this is a Boeing 787, as you can see, the most beautiful aircraft. Very beautiful to fly. So we keep climbing over here, make a small right turn. Can turn on the traffic maybe on the display. You see take us off. because sun will give us the other traffic, so we keep climbing. Make an alignment over here, and we have a few more minutes for this flight. We start turning. So we have an aircraft here coming in. We need to avoid. So now we can connect actually the autopilot if we need. Autopilot engage and also decrease. We need to level off for a couple of seconds over here as we fly. So we have this aircraft coming in. See, we can connect the autopilot like this. Autopilot engage, and we have the vertical speed also decrease to increase the airspeed actually. Have more airspeed. So now we have the autopilot connected here. You can see autopilot engaged. We climb with a smaller LNAV and vertical speed, as you can see, and we follow the flight plan also in the vertical. So this is the autopilot engaged, this white light over here with the LNAV and the vertical speed over here. So we follow now the flight plan here, the first waypoint, the Nigria. Then we're gonna make a turn, so stabilize the turn. Also we have the autopilot here displayed in the navigation display, in the head-up display, so we can see where we are right now. Overflying here this beautiful view, overflying Switzerland, and also have over here the lakes, the Switzerland, the Germany, Bayern Munich, my homeland in front of you, and the France. So we're going for turn. We're gonna make a turn, override a waypoint like this. 2 waypoints actually. Press the execute. We're gonna be turning over here. And elevate the airspeed a lot as we can. So now we make a turn with the autopilot on, as you can see. Keep having actually the flaps extended, autopilot on. So we overflying Germany here, Bayern Munich, as you can see, my homeland, the Boeing 787. So we overfly Germany, the lakes, the France behind us. And we turn back to Switzerland. We have the Swiss Alps, the Switzerland, and we move into the flight plan. So we take the flaps up, increase the airspeed like this. We're gonna have a higher airspeed. So you can see we fly now with the autopilot, no hands on the flight controls, no need. This is how the aircraft turns automatically, pretty much similar with the manual flight, but we need to fly commercially. We connect the autopilot for the cruise level, as you can see, autopilot on. Autopilot here with the LNAV in the vertical speed, keep climbing, and autopilot also here in the panel. So we overflying here this very beautiful view outside Germany, the Swiss Alps, my homeland Germany, Bayern Munich behind. So we disconnect the autopilot now, flying manually. So we can re-engage the autopilot like this. Keep flying over here. This altitude, beautiful view. The star sign also, as you can see, beautiful star sign over flying Germany, Switzerland, beautiful Switzerland, Swiss Alps and the France. The Boeing 787 flying at 26,000 feet right now. We need to start the descent in a couple of minutes. So we're gonna start descending. We're using the autopilot. We need to lower the altitude like this. And flight level change, the vertical speed again is a descent rate. As you can see, with the autopilot again engaged, we can descend like this. Idle thrust and speed brakes extended. So we have the airport here on this side, and we initiate the descent. As you can see, we leave behind the Germany, the France. Keep descending, as you can see. And we have 5 more minutes for the video to end, approximately. We are descending the aircraft right now, as you can see. We disengage the autopilot, keep descending a little bit further, 18,000. So we disengage also the auto throttle. Auto throttle off. Also here, keep descending. You can see the arc mode here. Now we have flight director on. We fly manually. As you can see, we can see the arc where we will descend at 7,000 feet approximately. So now we fly manually. Also the other side. And the waypoint we need to cross, Osnem. So we make the turn here as we descend for approach and landing. Keep descending. A little bit left rudder for descent over here. Increase maybe the thrust control. So we have like 4 or 5 minutes more for approach and landing. The aircraft as we descend 10,000. It descend a little bit steeper. Use full left rudder now for this turn. As you can see, left rudder pedal, left rudder. We need to align with this line over here where is the runway. Also increase the rate of descent. So now we are aligned with the runway for approach and landing as we are descending over here. We use the long final over here, as you can see. We have some side wind, Lszh localizer, so we're going to be aligned again, landing gear in a couple of minutes down. Also, you can see the runway here, so we have spotted the runway, landing gear down over here, flaps also are extended. So we're going to be having the view for approach and landing. So you can see we have the Lszh localizer. We have some side wing and some wind gusts. We need to align with the wind gusts. Also use more flaps as we descend, and a little bit more airspeed. So now we approach for landing, as you can see. Also we have the Lszh localizer here. Need to use the Lszh localizer in any moment to align with the data from the airport, the runway, as you can see, as we are approaching for landing. So we follow the Lszh localizer alignment. Also have some side wing, some wind gusts. We need to use cross controls like left rudder or right rudder. Now we use the right rudder pedal and right ailerons and spoilers, right turn. So we need to maintain the center line of the runway as we are approaching over here for landing. So we're gonna make a nice landing here, a bit less thrust to the engines, increase the rate of descent here. Use right rudder now, left rudder now. So we need to maintain the center line. Also use a little bit more thrust, so we increase the rate of descent. Align with the center line. We have the wing component, so maintain the center line. Now with flare, we're leveling off for the flare. Very beautiful touchdown, very professional. Idle thrust over here, thrust reverse, full thrust reverse, and parking brakes, also parking brakes, and full thrust reverse. So we landed, made it, as you can see. Very beautiful thrust reverse, full thrust reverse. Slowing down. We use idle thrust reverser here if we need, or full thrust reverse again. You see how it engages. So you can see all flight controls here are normal. There is no breakage. Also the landing gear of the aircraft, we made a very beautiful landing. So the landing gear, all the wheels and the nose wheel are perfectly safe, as you can see. Also the runway around us where we made the landing. Very beautiful view. So the aircraft is standing up the way it should be over here in the runway. So you see the nose wheel, there is no breakage of any part. So this is the Boeing 787, just landed. Again idle, thrust reverse, locked. So all the systems are safe, as you can see inside the aircraft after the flight. Also the computer here. So this was Thomas Hatsios, the German-American pilot flying the Boeing 787-900. Thank you very much for watching me. We just landed very safely. We made a very beautiful flight. I'll see you next time. Thank you very much. Bye bye. Bye.